Alright, so the nitrogen cycle starts with atmospheric NO2, and the first step in the cycle is actually nitrogen fixation, where the N2 is converted through bacteria, and then it hold up, here I need a pen, and transfer through nitrogen fixation, and then down into NH3, which is ammonia, and then is transferred again into ammonium, which is the process of ammonification, which actually happens over here again. And then so from there it assimilates into our friend, the plant. So the plant it assimilates the nitrogen, and then it is transformed into the consumers. When the consumers die, they either are decomposed or they go right back into the soil, and then it's ammonified again. And then you have to nitrify it, which is done by nitrifying bacteria, where basically they just take the ammonium and they take out all the hydrogen and they add oxygen, so you actually get the transformation of NH4 to NO2 and then to NO3, which is right here. And then you have denitrification, which actually transforms it back into N2O right there. And then you take it back into NO2. That's the nitrogen cycle. So the next up we have the hydrological cycle. Basically, it's just the water cycle. It starts with evaporation down here. Oh, hold on. We start with evaporation that's down here, and the water is actually evaporated from the oceans, which leaves behind all the chemicals and the salts, which actually makes the ocean more, having a higher salt concentration, and then pushes it all up into the sky, where it's pushed into clouds, formations of clouds, which, as evaporation occurs more and more, the water just absorbs it, and then it just kind of gathers until it condenses, and then it can no longer be held by such cloud, and then it's precipitated down to the ground right here, as you can see. So water is actually traveling up through the cloud, and then it's condensing, and it's coming down, and it's precipitating down, 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 and then it actually, when it hits the ground, it gathers, which is called percolation, which is actually the next step in the cycle. And then, so it percolates, and then it goes right back. It's absorbed into plants, or it's put right back into the ocean. When it's taken by plants, it goes through what's called evapotranspiration, which basically just the plants absorb it, and then they release more, and then it's evaporated, and it goes back up to the cloud, and it precipitates again, and then it percolates again, and you get a cycle. So the first step is evaporation. Second step is condensation. Third step is precipitation. Fourth step is percolation. It's over here, fourth step. And the fifth step is evapotranspiration, or you can have it go right back here and then just starts all over again. That is the hydrological cycle. So next up we have the phosphorus cycle. The phosphorus cycle is actually unique compared to all the, the hydrological or the carbon or the nitrogen cycle, because it is the only cycle that does not originate in the atmosphere. It doesn't take chemicals from the atmosphere and puts them into other things. It actually takes ions and the phosphorus chemicals from rocks that exist in the lithosphere, and then eventually in the hydrosphere, and pushes them through the cycle. So you actually start with rocks. The rocks can be underwater. They can be in volcanic ash. But basically, they just get eroded by time, by water, really anything. And then the phosphorus is released through erosion. And then the water, it allows the phosphorus to run and transfer. And then it's put into plants. And the plants are, they absorb it. They put it into a usable state. And then after it's put into that usable state, it kind of transforms. It's eaten by the animal, and then it's put into something that can actually be used. And then after the animals die, decomposers put it back into the soil. So it exists in all down here. And then because it exists in the soil, it has the ability to either turn back into a rock or be absorbed by animals to be eaten again. And that creates the phosphorus cycle. Lastly, but not least, we have the carbon cycle. The carbon cycle, it starts with atmospheric CO2, no matter where you're looking at it. And atmospheric CO2 is then absorbed by plants, who absorb it using photosynthesis, and they actually use it to break down. They use it to break down chemicals. It's part of their respiration process, right here. So it comes down to respiration, and then it can either go through the respiration process, or it can come down and be compressed. As plants die, they settle, and it creates rock, and then which then turns into fossil fuels. If it is turned into a fossil fuel, then it has to be extracted from underneath, in the fossil fuel reserves, and the extraction is then followed by a combustion reaction, which then releases that same CO2 up back into the atmosphere, actually completing that part of the cycle. But that's the fossil fuel route is actually abiotic, which means it doesn't have any living components in it. But this biotic cycle, and the biotic is up here because it involves the plants, which is living. The biotic is then transferred, because it's absorbed by photosynthesis. By the time you get here, there's no living products, which does make it the abiotic cycle, because the plants have died and are being compressed. The biotic cycle goes from photosynthesis to respiration, and then there's an even exchange between either atmospheric CO2 with the plant exchanging with what it needs, or you can actually have an exchange in water. You can have dissolved CO2, which actually happens, dissolved CO2, which actually happens in water, and you see it in underwater environments a lot of the time. But after that exchange has happened, it can either go back into photosynthesis, or it can just go back into the atmosphere. And that completes the carbon cycle.